A monsoon is a very special kind of climate system. It is classified in terms of a prevailing strong winds that reverse distinctly as the season. And also it is described by a very distinct wet and dry season. The rainfall that fall within that wet season should be more than 60% of the entire year.
The fundamental drive for the monsoon, both in India and other parts of the world, is that there's a large area of land which gets warm compared to the surrounding ocean. And that surrounding ocean provides the moisture which is then driving the precipitation that constitutes what we think of as monsoon.
If you simply look at the Asian monsoon, you can estimate, and various estimate, more than 60% of the world population live right in that area. And the monsoon, the water provide the fresh water supply for this population, not just for the daily life, for agriculture, for the industry. And so the entire region, the people's livelihood depend on the very delicate balance of the water balance in that region.
GPM gives us the chance to look at precipitation around the world. And so in addition to the hurricanes and typhoons, we're also looking at the monsoons because those storm systems are very important for driving floods. And the advancements in GPM will allow us to do a better job of providing precipitation information so they can make better forecasts of the floods.
Monsoon is not just simply a local problem, a curiosity. It actually has a huge amount of societal impact in terms of how it changes in that region. The economy in that region can affect the entire world, as well as many, many things that happen in that region. GPM has the most advanced dual frequency radar that actually measures the vertical structure of the rainfall itself, and that's very important.
The DPR gives us an unprecedented capability of teasing out relative sizes of particles, and this is really important for understanding how the microphysics, the rain process works and the snow process, and also how those can then be represented in numerical models that are critical for forecasting future events.
To study the monsoon, one thing we didn't know is to know what we call the predictability of the monsoon. How well can we predict the monsoon at that time? And in order to do the prediction, we need to have to know the variability very well. This ranges from daily to weekly, seasonal, and then to what we call decadal variability.
The monsoon was first named in India, but it turns out that the same driving force happens in other parts of the world. And so, for example, in the Northern Hemisphere summer, you have monsoon in West Africa, you have the monsoon in southwestern North America, and then in our winter, the Southern Hemisphere summer, there's a monsoon that happens across northern Australia. The great thing about GPM is that it allows you to see the rain systems as a whole. You get to see them over the ocean and over the land. You can see what the transitions are. And so even before it gets to land, where we have surface observations, we can tell what's going to come in. We can see what's been happening. And of course, scientifically, that also allows us to understand the complete water cycle that's taking place in the South Asia region.